That's it.
All right, let's go to the first slide. As soon as he has it pulled up there.
And I just use this pad here.
Yes, sir.
Okay.
So we
tap
have,
to advance.
here it
Just
is.
tap.
Native Hawaiian organization, great group we've had involvement with since Land Pack last year. We look forward to seeing them again this year.
Yeah.
And Keone is the head of DIBSHawaii and has really worked very hard to try and find good applications for the technologies that in an innovative manner for his technology he'll describe here for the use with military systems.
Thank you, Bruce. And I wanted to thank AUSA, Bill Garland, and Dr. Bruce Jetty for inviting us out again to Innovators Corner. So I greatly appreciate that, and aloha.
Aloha.
So today's presentation, my name is Keone Ford. I'm the owner of DIBSHawaii. DIBSHawaii is 51% owned by a nonprofit. So we do have our 8A vehicle moving forward to do advanced surface preparation using dry ice cleaning. So we'll go ahead and begin this presentation. Little heads up on this presentation, I decided to go with a lot of video because I find sometimes talking about technologies, it's a lot better to see. So a lot of this, you'll see a lot of videos to this presentation showing actually live applications and how quickly and how effective these techniques really are. So the first key thing about dry ice is it's inert gas. So we are using CO2, which is reclaimed from industry. We are liquefying that CO2 and we're turning it into dry ice. And the dry ice can be made into 3mm high density pellet. We can convert that into blocks, and we have a bevy of applications. Our ability to change the particle size, the intensity, and so our ability to clean non-toxic. It's non-destructive, so our ability to clean at very low pressures, in some cases it's 15 psi, all the way up to 200 psi. This is advanced surface preparation, so this leaves no secondary waste stream. We are using a gas, so our ability to clean on time, on line, and leave no secondary waste stream. So basically how dry ice blasting works is you take a CO2 particle and it's accelerated at supersonic speeds. As it hits the substrate, it impacts and it sublimates, expanding 800 times its volume. So you'll see a slow motion video here of what's happening is the particles are actually coming out, accelerating to supersonic speeds. On impact, instantly sublimating, dislodging the contaminant away from the substrate, and then the gas is carrying the contaminant down. So what we're doing is we're basically taking the contaminant from the substrate and displacing it to somewhere else, leaving no secondary waste stream. So you can see the large cloud happening. That's instant sublimation on impact. You'll see a little cloud here going in a second, and that cloud does drop, and that's typically where the contaminant is. So this kind of slow motion video of what's actually going on. So here are the key advantages of dry ice. If you can't get it wet, how do you clean it? The surfaces must be free of residue or contaminants. A lot of times that involves putting a surfactant to release that contaminant away from the substrate, at which point you need to rinse it and wipe it down. So if that can't be achieved, how do you clean it? If hazardous waste is a concern, what are we doing? We don't want to add any secondary waste stream, so we don't want to add in grit. We have to pick up the water. How do we grab the sand that's now contaminated? Now we have to dispose of it. And that's another key place where dry ice can fit in. Grit entrapment issues, very important. Critical tolerances, maintaining service dimensions, non-destructive testing. Current cleaning methods, currently very labor intensive. How do we clean it? We have to take it offline, disassemble it, use chemicals, solvents, wire brushes, put it back together. Hopefully it's working. We have to take it out of production. If we can't do that, how are we cleaning it? Typically, it's neglected. It's not clean. Again, the key piece here is there's no secondary waste stream when we are cleaning with CO2. So this is an example. The Corps of Engineers, I just wrote this spec. We finished this job just in February. The Corps of Engineers, Schofield Barracks, pushed forward and innovated in requiring that we use dry ice blasting to come in and remove mold growing on loose and flaky lead-containing paint in a historic structure. So that was a kind of very complicated situation. They decided to move forward and try this technique, and we got incredible results. It went far beyond the scope of work of removing loose and flaky paint, and we're going to go through some of the data that we collected and some of the videos along the way so you guys can actually see live what was going on in this project. So this is what we saw. We had 4 bathrooms in a historic structure. It was blasted. I mean, it was covered up with mold. There was major issues going on, and this is, you know, this happens. We see this in bases. So what we have is the mold growing on these loose and flaky lead-containing coatings. And how do we get this building ready to turn back around? So DIBSHawaii was called in to use our innovative cleaning techniques, and so here are some of the results. You can see the gas is instantly sublimating. The cleaning time on this project was incredible. I mean, as we're cleaning, you can actually see we're cleaning, disinfecting the surface. So there's 2 things that are happening in this video, 2 forces. The first one is the kinetic. We have that explosive force of the CO2 media expanding 800 times its volume. So the kinetic forces. Dry ice is a negative 109 degrees. So because it's so cold, it kills bacteria on contact. So its ability to work in food industry, it does kill E. coli, listeria, and so forth. So it does have that capability. So we came in this scope of work. We did have mold. We did pass all our samples. So mold was present when we were done with the job. We did the white samples, and there was no bacteria present. There's always mold all around us, but the levels were significantly reduced, and we did pass in the first run. So you can see killing the mold and then going in and removing loose and flaky paint at incredibly high speeds. So we did a job that typically would have taken about 30 days, and we did it in 6 days. Here's the before and after of the same area. The process is so delicate that it literally leaves almost a patina still intact. I mean, so it's dry, it's clean to touch, and it's ready for inspection. So one thing that we did here was we were able to clean, but we actually had a lot of other key pieces happen where we could actually start to inspect the structure to see if there's other things that were missing. So we had some really favorable results. Here we go. Exposing faults for critical inspections. It was quick, effective, again, non-destructive, and no secondary waste stream. This particular application, we're cleaning at about 65 PSI. That's almost nothing. But you can see there's concrete buildup on the black pipe. Our ability, a scraper couldn't even take the concrete off, yet we're coming in with the dry splashes, and you'll see here in a few minutes the ability to come and clean and polish the copper. We were able to remove the concrete splatter on the concrete piping, enabling it to be inspected to see if there was any damage before it gets put back together, preventing any potential leaks downstream as we're getting the building back online. I think you guys get the idea with that. Here's the before and after on this application. Again, we were called in to do loose and flaky paint and mold, yet we were already there, so we just went ahead and did all these pieces for them, value added, again, to the project, and results were spectacular. They did a wipe test with their fingers. I mean, this was dry and clean and ready to go. So again, there's a lot of value added parts to the work that wasn't even initially in the scope of work. So we were there, we went ahead, let's do it, let's take care of it, we can do it quickly. This video, what you'll see is we do have loose and flaky paint, but what I want to illustrate is our ability to remove things a layer at a time. So this video will really truly illustrate how we are killing the bacteria, super chilling the substrate. Once the substrate has been cooled, we now have the ability to come in and actually have the coating start to really pop and fail. So in many cases, what doesn't look like a loose and flaky scenario, you could have large sections ready to fail when it comes back and turn around. So our ability to come in and use this process to truly expose what is going on. So in this video, you just start to see, once we cool it, we kill the bacteria, but you start to see a large popping of these coatings coming down. In many cases, you know, we're removing some to 30 coats of paint. I mean, this building's from 1930. So we saw some pretty significant results in this job. For 4 bathrooms, we removed 1,000 pounds of coating from the ceiling with no secondary waste stream. All right, so for that job, we used 6,000 pounds of dry ice over the duration of the project. When we recaptured all of the paint chips, we had it in 2 barrels. 6,000 pounds of media was used. Again, no secondary waste stream. We had 1,000 pounds of just paint chips that we recovered that went into 2 barrels. So you guys can see the effectiveness of that, where we didn't have to dispose of that additional weight. So I'm going to go ahead and show you another multitude of the cleaning applications. This is what we did for the core. We're really excited about that. We wrote the spec on that. We pushed forward. Here is really why I feel this technology should be emerging and how it can truly help reduce the life cycle costs of the equipment out there. So our ability to come in and use total preventative maintenance programs to come in and use advanced surface preparation techniques to clean, to bring back existing equipment back into service. That way we can, you know, we can continue to use without having to bring in brand new equipment. Again, that was some of the things that we heard over the last couple of days. So here are just some of the multitude of cleaning applications that can be used along the way. So this is a pilot program that I ran for the Navy. We did electrical online cleaning. This is on the USS Peleliu. I was brought in to run this pilot program. We got incredible results in this. What you see here is a 450 hertz board. It's never been cleaned ever. We had an opportunity to go in there and clean it. In about 20 seconds, we got these results. Again, these systems were online, never had to be disassembled. So online, on time, keeping production in place. We saw 1,000% increase in electrical resistance after one cleaning. This was incredible. We did not expect to get these results. We had to actually have electricians come in a couple of times. We had to test electricians, test the equipment, test them again. The end result was we truly did get 1,000% increase in electrical resistance. So very impressive what we did here. Again, we did this in incredible times without any disassembly. You can see the dry ice is so gentle in that we were able to go ahead and remove the failed coatings, but yet we kept the danger sticker in place. So again, that, you know, a lot of wonderful things when we start getting into the finesse out in the field using the dry ice cleaning application. Here we have a brand new air handler. A lot of times mistakes happen out in the field. In this particular case, a contractor got overspray on the critical fins on a brand new air handler. Those coatings baked out in the sun. They had to turn around. Passed the building on for inspection. Well, you know, they were stuck. They were going to have to come in and replace all those air handlers. They brought in DIBSHawaii. We came in. We came in with low pressure. We used dry ice dusting techniques and dry ice fogging techniques, coming in at 15 psi. They tried to use pressure washers. Pressure washers wouldn't take it off. The dry ice came in at 20 psi and was able to remove 90% of that, and it did pass. So that was a really challenging one. Again, those incredibly delicate, those fins. This is what we did. This is a Hawker. This is a Canadian fighter plane that's used at Marine Corps Base to train. So they brought the plane in for maintenance off-site. It's a Canadian plane. They demanded that dry ice cleaning take place to come in and do critical inspections. So we got some really favorable results on that. Okay, this is oil residues. This happened in Hawaii U.S. Coast Guard. There was oil spill on a Matson container. Heavy removing oil and grease so that these could get released back onto the trucks and out on the street, and the cargo could be delivered. They sourced dry splasting to come in and to remove this without using any solvents, caustic, diesel, scrubbing. We had incredible results. Here's some video to show you how quickly we did this. That's your end result. Again, no solvents, no secondary waste stream. The oil was collected onto the mat. Mat was disposed of. Okay, corrosion, something that we see a lot of. Our ability to come and be non-abrasive, non-destructive on eliminating corrosion, in which case things can be recoated, re-prepped, and then get it back in a cycle. So incredible results what we see on light corrosion. Again, it is non-abrasive, so it will not profile metal. Now it will clean the surface, at which point if there is already a profile in place, it keeps it intact. So dry ice is used to, it's mainly a cleaning process. So if it's a failed coating, it'll come off. If it's a well-adhered coating, such as a really good primer, a bond, and the surface still has a profile, it keeps the surface profile intact, in which case we could just come back in and repaint. So it's really exciting when we can come in, as long as the spec can change. If it's not required to profile, then why are we coming in to profile it? Here's some more light corrosion. And this is a dry process, so I mean, immediately following this could be turned around and coated and put back into service or installed. Again, critical surface dimensions aren't affected. Along the way, you've probably seen a lot of different nozzles, so we got hundreds of different nozzles for so many different applications. Again, this cleaning probably taking place, I'm thinking around 35 to 40 psi using microdust particles. Okay, and finally, engine cleaning. I think this is a really exciting one. Everyone's got dirty engines. We use pressure washers, solvents. If we have the ability to clean it without using these solvents, what to the extent does it do to the service life of our equipment if we have the ability to come and clean a dry, light process that's non-destructive? What kind of service life, what kind of extension does that give to our equipment? I wish I could put this in slow motion. What you actually see is the dirt being lifted up, and then again the CO2 gas carrying it down. So it happens really quickly. Again, it's dry to touch. This was just kind of a fun one. I just wanted to get the dirtiest engine we could, and we used about 1 pound of dry ice to do this. Again, a little review of when we'd want to use dry ice and what the advantages are. If we're faced with challenges around water and chemicals and they can't be used, how are we cleaning it? The surfaces need to be free of residues and contaminants. How do we achieve that? Hazardous waste is a concern. Case Army Corps of Engineers, we had mold and lead paint. we use this process. Grit entrapment issues, maintaining surface dimensions, always very important. To me, that's finesse in the field, being able to use, come in and use light, driest dust particles, cleaning 15 PSI, electronic components, very important. Labor intensive, extensive disassembly, and again, no secondary waste stream. I can't stress that enough. If we blast with 5,000 pounds of dry ice, we pick up 0 pounds of media. And non-toxic, non-destructive, advanced surface preparation, dry ice cleaning, non-abrasive. Thank you so much. If there's any questions, I'd be happy to answer them. Thank you. Yeah, thank you.
Questions? All right, don't get away that easy. People may have some dry ice questions here. Here's a quick question for you. I'm an operational element and I need dry ice cleaning. Where the heck do I get the dry ice?
You know, that's a very good question. In fact, that discussion is a topic for Innovators Corner just by itself. So I've been working for the last 3 years to get mobile dry ice production into place to support these applications. Now, what I'm showing you is really neat. I mean, it's cool, no pun intended. Negative 109 degrees. You can't do any of this if you don't have dry ice. And so I've been working with Cold Jet to create a mobile dry ice production unit, as I call it, MDIP. So we are working with the Navy. We do have an MDIP model in the works right now. It's in a 20-foot container, so we have the ability to make dry ice specifically for our cleaning applications. So we can get dry ice out into the field. To further that note, dry ice is an incredibly inefficient process to make. So it does come from the industry, but typically it takes 2.5 pounds of liquid to make 1 pound of dry ice. So I've been waiting for a long time to work with industry professionals, to work with Cold Jet, to come to a place where we can really expand the amount of dry ice, because that really changed our effectiveness. So 2 weeks ago, we got through R&D, we passed rigorous testing, and Cold Jet is going to be making a recovery system for me. Then we achieved a guaranteed 1.5 to 1 ratio. So we're doubling the amount of dry ice that we can make out in the field in this 20-foot container mobile dry ice production unit. So I'm really excited about that. And maybe I could talk about that by itself another day.
Okay. Maybe you should bring one with you one time.
How do we get that out to the science and technology people?
Yes, we need to find better ways to do that. Other questions? Okay. All right. Well, Joni, thank you.
Thank you, sir. Mahalo.
Aloha.